Okay, everybody, thanks for coming to Seattle. It's great to see everybody here. I'm going to talk about 573. In some sense, it's hard to really define what AI is about unless you define intelligence, which is known to be impossible. So really, are we trying to do that? Hopefully not. There's a couple ways you can define intelligence. One is just saying, well, we've got an existence proof. It's about people. Let's make computers that act like people or that think like people. The other one is to try to define some sort of optimal behavior. Economists like this notion of rationality. And that's the approach that we're going to take, not so much worrying about thinking optimally, but about acting optimally. How do we build machines that act optimally? To do that, we like to take the framework where we've got an agent that senses things from its environment. Environment might be static, might be dynamic. And then the agent can execute actions that possibly change the environment. And we've got this sort of control loop here. And this is a very, very general framework, and it's the one that we'll adopt for most of the class. So really, we're basically going to be looking at different types of environments, different types of situations, and what kinds of algorithms can we use to behave in a resource-bounded, optimally way. So to make that concrete, let me give you a couple examples of agents. So a fair amount of publicity around IBM's Watson system that pretty convincingly won the game of Jeopardy. Here's an example of a autonomously driving car that passed the DARPA Urban Challenge. Up there we've got Mars rover, again guided by AI techniques as it tries to maximize the value of science experiments. And really anything, it doesn't have to be a robot, anything can be viewed in this kind of a situation. So here I've got a complex network where again you've got some sort of utility function you can define in terms of how quickly packets are moving around, and there's no reason why we can't try to use AI techniques there, or for pretty much any of the problems that we confront in the world. I wish I could have us building robotic cars, but I'm going to adopt a simpler environment in the class and use a set of assignments around Pac-Man developed at UC Berkeley. It's really a great set of assignments for illustrating some of the basic algorithms. We're going to go through this really quite quickly. So about the first half of the class is going to be dealing with Pac-Man. And just to give you a sense of that, first we'll start off with a very static environment, just trying to figure out how to make our way around us. That introduces the search ideas. Then we'll have some agent out in the environment that's competitive, and we'll look at game playing algorithms. Then comes the more interesting cases where we don't necessarily know how the environment operates, and we have to use machine learning to build up a model of the world and use planning algorithms to figure out the optimal way of executing. So that leads us to things like Markov decision processes, algorithms like value iteration and policy iteration, and reinforcement learning for driving the whole thing. And then finally, we'll talk about uncertainty and what happens when those percepts that are coming back from the sensors are giving noisy information, and how can the agent represent the state of the world using probabilistic methods and efficiently figure out what it should do next. So that'll lead us to particle filters and a number of other algorithms. So that's going to occupy the first half of the course. And in the second half of the course, we're going to move on and talk about a number of more advanced topics, including some of the ones there. Meanwhile, at this point in the course, you guys will have proposed the project you want to do for the rest of the course. And so the second half will be focusing on these advanced topics, and you guys working in small teams can do whatever has you guys jazzed, applying AI to whatever, or doing some experiments on algorithms. So I'll have a bunch of suggestions for that, and you guys can come up with your ideas too. We put this class in context since there's so many people pitching classes at you. I've tried to take sort of, used to be that all there was AI, and then a whole bunch of subdisciplines have split off. So you can see that we have a whole bunch of courses. Color system is the blue courses are Quals courses. The red courses are advanced graduate courses. You can see a whole host of AI-related topics. I think AI maybe it's just sort of subtly a little bit bigger and in the center because, well, is it because it's the most important or just because I'm teaching it? I'm not sure. But it really gives you a great foundation for exploring all of these other topics, whether it's comp bio or Carlos Gistron's going to give a talk, give a class on big learning, a whole set of exciting classes. These two classes are shaded out a little bit because they're not offered this year, but put them on your list for things to take next year. Okay, so let me end with a final word. So I've sort of talked up until now about how do we engineer these kinds of complex systems in dynamic environments so that they can optimize some sort of utility function. But we, of course, are the Department of Computer Science and Engineering, so let me just spend a word talking about science. It seems to me that there's really three fundamental scientific questions in the world. And the P versus NP thing you guys have been, that's not one of them. Okay, what are the questions? First one is, where the heck did the universe come from? Kind of profound, I don't know. But that's not us. Next one is, wow, biology, life. Origin of life. Profound question. And the third one is really about the nature of intelligence. And we own this problem. I mean, computer scientists, we owe it to ourselves to study this and figure it out. It's really one of the most exciting and fun things. And I hope to see you guys in 573. Forgot to write down where it is. That's a useful thing. It's in EE54, I believe. Starts on Wednesday, so it's Wednesday and Fridays at 1:30. And hope to see you guys soon. Any questions? Yeah.
Taking an ad class, is it worthwhile to take this one, or is it better to do something?
You know, that's a great question. What you should do probably is meet with me specifically, and we can talk about what you might have taken in a previous class, and whether there's more overlap. You know, whether it's going to be useful to you, or whether you should just go on and take a more advanced class instead. It really depends on the undergraduate class. So yeah, let's talk one-on-one. Other questions? Fantastic, thanks.
Thanks very much.